Let's go ahead and do some examples for the hyperbola. So the first example I want to do is to write the equation in standard form. And this equation, or this hyperbola, has vertices at 3, -3 and 3, 3. And then it has a focus at 3, 5. So let's go ahead and find the equation from given this information. So in order to determine what equation we're going to use, first I'm going to go ahead and draw a sketch of this. So 3, -3 and 3, 3. So 1, 2, 3, 1, 2, 3. So that's 3, 3, 1, 2, 3 going down. That's 3, -3. And then the focus is at 3, 5. So we know it's a hyperbola that's going to go and open up and down because the vertices are aligned vertically. So if it opens up and down, we're going to go ahead and start drawing or writing our equation with the y's because it opens up and down, and these are vertically aligned, or they're parallel to the y-axis. Then the y is going to go first. So we don't know how wide this is going to be. We're going to determine that later when we actually graph it. This is just a sketch to help me figure out what formula I'm going to use. So the formula is y minus k squared over a squared minus x minus h squared over b squared is equal to 1. So the a squared is going to go under the y if it opens up and down. It would go under the x's if it opens left and right. So we need to go and find hk, which is a center. We're going to need to find what a is equal to, and we're going to need to go and find what b is equal to. So let's first find the center. The center is going to be exactly halfway between these vertices. You can use the midpoint formula if you wanted to. So it's going to be x1 plus x2 divided by 2. So 3 plus 3 divided by 2 gives me a 3. And -3 plus 3 divided by 2 gives me a 0. So this center is going to be 3, 0. You can also find the point that's exactly halfway just by looking at it. For this one, it's easy enough. So this one's going to be at 3, 0. And then the distance between the center and the vertex is equal to a. So the distance between 3, 0 and 3, 3 is equal to 3. So that means that this distance is a equals 3. And this point was at 3, 0. This 3 and this 3 have nothing to do with each other. So this 3, 0, this 3 comes from, you go 3 units to the right so that you align it vertically with the vertices and the focus. And this 3 is the distance between the center and the vertex. So we know a is equal to 3, but what is b? So in order to determine what b is equal to, because they didn't give me what b was equal to, then I have to use the relationship between a, b, and c, which is a squared plus b squared equals c squared, and that's the same relationship whether it opens up and down or left and right. So a squared plus b squared is equal to c squared. So a squared is 3 squared plus b squared, b is unknown, is equal to c squared. So c, what is c equal to? We're also missing c. So we can find c by using the focus. The focus is c units away from the center. If the center is at 3, 0 and the focus is at 3, 5, then the distance between these two is 5 units. So that means that c is equal to 5. So I'm going to plug in a 5 for the c squared, or sorry, for the c, and then we're going to square it. And then if we solve for b, b is going to be equal to 4. So that means that a is equal to 3, b is equal to 4, and the center is at 3, 0. We have everything to write our equation. So y minus k squared is now y minus a 0 squared divided by a squared, that's 3 squared, minus x minus h squared, so x minus 3 squared over b squared, and b squared is 4 squared, and this is equal to a 1. So now what we're going to do is we're going to go and find, we're going to go and simplify this. So this is y squared over 9 minus x minus 3 squared over 16 is equal to 1. So this would be the equation in standard form. Now if I wanted to go and graph it, let's go ahead and actually graph it to scale. So let's write down the information that we have. So we're going to graph, and we're going to use the information that we had, which is A was equal to 3, we had B was equal to 4, we had a center at 3, 0, we had vertices at 3, negative 3, and also at 3, 3, and then we had a focus at 3, 5. So A is equal to 3. This tells me the distance again between the center and the vertex. So in this case, because it opens up and down, I'm going to go up 3 and down 3. B is the distance between the center and the right side of the fundamental rectangle, or the left side. So we're going to go to the right and to the left by 4 units. So let's go ahead and draw this out. So center is at 3, 0. You go 3 units up, 1, 2, and 3. And this gives me the vertex. The first vertex, 3, 3. And then the second vertex, 3, negative 3, is if you go down by 3. So 1, 2, and 3. And that gives me the second vertex. Now to use B, I go 4 to the right and 4 to the left. And that's so that I can find the fundamental rectangle. So this is 1, 2, 3, and 4. And this is 1, 2, 3, and 4. These dots that I just drew, they're not actually part of the hyperbola. They're just going to be reference points. So we draw our fundamental rectangle touching all of these points. And then we're going to go ahead and draw our asymptotes going diagonal. So going through the corners and the center as well. So we go through the opposite corners and the center. And this is what's going to determine how wide my graph is going to be. So let's go ahead and draw the focus also. The focus is at 3, 5. So we go 2 up. And then the focus on the bottom is going to be 2 below that as well. When you draw your hyperbola, you're going to go ahead and use the vertex and the asymptotes, making sure that you approach the asymptotes as well. And then you go down and approach the asymptote, down and again approach the asymptote. So that would be my hyperbola. Let's go ahead and do another example. On this one, I'm going to give it to you in general form. It's actually a variation of general form, so it's expanded form, and then we're going to go ahead and find the equation in standard form. So let's go ahead and do the following example. So we had x squared minus y squared minus 2x plus 4y is equal to 12. And the first thing we want to do is write the hyperbola in standard form. Okay, so in order to write it in standard form, we're going to need to write it either into this x minus h squared over a squared way, or minus y minus k squared over b squared is equal to 1, or we would end up writing it this way, where the y's goes first and then the x's go second. So look for the minus sign. So look for the minus sign, but in front of the y's being squared or the x's being squared. The minus sign in this one is in front of the y being squared. The positive is the x being squared. So then that means that the x is going to go first. Whichever one is positive is going to go first. Whichever one has a negative is going to go second. So we're going to have the general form of x minus h squared over a squared minus y minus k squared over b squared is equal to 1. This is what I'm trying to get to. But we're going to rewrite this into this form. So let's go ahead and do that. First, we're going to keep all constants on the right side, all variables on the left. So this is x squared, and then minus y squared minus 2x plus 4y equals 12. Already has a constant on the right, all variables on the left. So then the next thing you would do is organize. Put the x's together, so x squared minus 2x, and then I have the y's, minus y squared plus a 4y, and that's equal to 12. So remember that when completing the square, in order to get a square, we're going to need to complete the square. And remember that when completing the square, we need a constant of 1 in front of the x being squared and also the y being squared. So if there was anything other than 1, you take it out. You factor it out. So in this case, we just have x squared minus 2x, and then we have minus, and I'm going to take out that negative also. Y squared minus 4y is equal to 12. So we take out this negative. It can only have a positive 1 in front of the y squared, positive 1 in front of the x squared. So then we're going to go ahead and complete the square for the x's. So let's go ahead and group this. We have x squared minus 2x plus something. And then we have minus y squared minus 4y plus something else is equal to 12 plus what comes from the x's plus what comes from the y's. So for the x's, we're going to take this negative 2, we're going to take the b. For the x's, negative 2 divided by 2, we're going to square it. We get a negative 1 squared, that's equal to 1. So put a 1 here. There's nothing in front of it that we took out, otherwise we would take 1 times that quantity that we would have taken out. So in this case, it's just a 1. And for the second one, we're going to go ahead and take the negative 4. We're going to divide it by 2, so negative 4 divided by 2, and then square it. This gives me a negative 2 squared. That gives me a 4. You put a 4 here, but then you have a negative here. So 4 times negative 4, we need to balance it, and that gives me a negative 4. So on the right side, it was 4 times a negative 1. And now we complete the square on the left side for the x's, for the y's, and simplify the right side. So on the left side, it's going to become a quantity squared for the x's minus a quantity squared for the y's equals, and then we're going to simplify this. So this gives me a 9 on the right side, and in the parentheses for the x's and for the y's, I'm going to take this number on the inside, negative 1, and I'm going to take the number on the inside for the y's also, that's negative 2. Remember the hyperbola has a 1 on the right side of the equation. So we need to make sure that this is a 1 on the right side. If it's not, we have to make it a 1. So in order to make it a 1, we have to go and divide everything by that 9. So this gives me back x minus 1 squared over 9 minus y minus 2 squared over 9, and that's equal to a 1. So that's my equation in standard form for the hyperbola. So if we wanted to go and graph it, let's go ahead and do that too. So we want to determine, does it open left and right, or does it open up and down? So because the first variable that I see in here is an x, then that means that it's going to open parallel to the x-axis. So that means left and right. So we know it's going to open left and right. Let's go ahead and find the vertex. Let's find the vertices. Let's find the center. Let's find the A and also find the B. So we know that this A squared is equal to the 9. So let's go ahead and solve for A. So A squared equals 9 means that A is equal to 3. And B squared was equal to 9 also in this case. So B squared equals 9 means that B is equal to 3. It just so happened that in this one, the A and the B are identical. It doesn't always happen that way, especially when you have a constant other than 1 in front of the x squared and in front of the y squared. So when you have to factor out constants other than 1, that's when these A and B's might be different. So A is equal to 3, B is equal to 3. So A equals 3 means that I'm going to go to the right by 3 and to the left by 3 because it's under the x's. And for B is equal to 3, that means I'm going to go up by 3 and down by 3, and that's because it's under the y's. So for the center, this is HK. Remember that the H always goes with the x's. In this case, we have a negative 1. You make it opposite, and that gives me a 1. The K is with the Y. That's a negative 2. You make it opposite, and that gives me a 2. So let's go ahead and use this information to go and graph it. So we're going to go ahead and draw our center. So this is at 1, 1, 2. And then go to the left 3, go to the right 3. So this is 1, 2, and 3, and 1, 2, and 3. So these vertices are points -2, 2, and this one is 4, 2. So we're going to also use the b, which is equal to 3, and we're going to go up 3, so 1, 2, and 3. And we're going to go down by 3, so 1, 2, and 3. We always start at that center, go up 3, and then down 3. And we're going to go ahead and use these in order to draw the fundamental rectangle. For this one, I'm actually going to go and find the equations of the asymptotes. So let's go ahead and draw the asymptotes going through the corners of the rectangle and the center, and you do the opposite corners as well. We knew that the center was equal to 1, 2. And if at this point you forget whether it was opening up and down or left and right, always go back to this equation here. I made a reference that it opens left and right, but why is that? Because the x's are first, then it's going to open parallel to the x-axis. So it's going to mean that it's opening left and right. So let's go ahead and draw that opening left and right. And approaching the asymptotes going through the vertices. Now let's go ahead and label some of these points. This vertex was at 1, 2, 3, 4, and the y value is 2. And this vertex was at 1, 2, so -2, and the y value is 2. So this is vertex, let me call this vertex number 1, vertex number 2. And let's find the equations of those lines as well. So you go a rise of 1, 2, and 3, because b was equal to 3, so this is a rise of 3, and a run of 3, so you go 1, 2, 3 to the right. So y minus y1 is 2, equals m, which is the rise over run, so 3 over 3, times x minus x1, which is equal to 1. And if you simplify this, you're going to get y minus 2 equals x minus 1, and if you wanted to move that over, you could. So this is y equals x minus 1, and then plus a 2. You could even simplify it further, y equals x plus a1. You could have just left it like this if you wanted to. So let's go ahead and do the other one. So y minus y1 is a 2, equals m, so it's rise, going up by 3, and then run, going to the left by 3. So I know it's up by 3 because the distance between the center and the top of the rectangle is b, which was equal to 3. And I know that the run is equal to negative because I'm going to the left, and I know that the distance between the vertex and the center is equal to 3 because that's what a was equal to. So then it's going to be 3 over -3 times x minus x1, which is a 1. And if you simplify, you get y minus 2 equals a negative times x minus 1. You can leave it like this if you wanted to, or you can change it into y equals mx plus b. So y minus 2 equals negative x minus 1, and then plus a 2. You could expand this if you wanted to also. So you could leave it like this, or you can leave it like this. It's really up to you. As long as you simplify that slope, then we're good. So you can either leave it in y minus y1 equals m times x minus x1 as long as you simplify the slope, or you can simplify it as much as you want. You can make it look like the equations that we have on the worksheet if you wanted to.